Right. So thank you for joining at 8 o'clock. Before we come to lists, let's satisfy Kaustub's question. So Kaustub asked if we can discuss the yesterday's solution, which is space complexity order 1, extra space complexity order 1, and time still order n, right, which is the length of the array. So one of the ways in which that can be done is that you can use the sign bit available with each element to keep track of whether that element is present or not. So whenever you encounter an element, let's say I, you set a of I to a negative value. Right? Whenever you encounter an I, you set a of I to a negative value, and that will make sure that at the end of one pass over it, you are going to encounter all the elements which were present there. Those indices are going to be negative, right? And therefore, let's say a of 1 is, 1 is absent in the array, then a of 1 is going to be a positive value. This requires that you would have done some pre-processing, because originally there might be negative values in the array, and that you will specify, that you will take care of, or either set it to 0 or something like that before you start making this procedure. Right? So if 1 is absent, right, so then you will not set a of 1 to a negative value. Similarly, if 4 is absent, 1, 2, 3 are present, then a of 1 will be set to a negative value, a of 2 will be set to a negative value, a of 3 will be set to a negative value, a of 4 will not be set to a negative value because 4 is absent. So if you make another pass just over from left to right, that will give you the first missing element, which is not there in the right. So this is more like a little different solution. Still, you would need an array of n size, right, to store the signs. Well, yeah. So that is a little tricky in the sense that, can you consider this extra sign bit as an similar to the bit array that we were talking about, right? That is Kaushik's question. You may, provided originally we had said that you have only positive elements in the array, right? But we said that there are actually negative elements also in the array, which does mean that you have that sign bit already available with you, right? And therefore you don't need an extra order n bit array. So that is what we can claim. Any other concerns, questions? Yeah, sure. Question. All right. So we'll start with this topic of lists. That doesn't mean that arrays are over. Arrays are, we have not done yet sorting. And there are a large number of all sorts of sorting algorithms are there, which we would like to learn a little later. This list is going to kind of get us dirty with both C++ as well as pointers, and that will be helpful for our assignment as well. As you know that the assignment is already released, and you should be familiar with HackerRank to complete the assignment. Those of you who are already familiar with HackerRank, it's all right. But those of you who are not, please make sure that you try out some problem on HackerRank so that you get familiar with the process. Note that you cannot have any difference, even spacing, in the output. Just a minute. Yeah, let me log out and join from a different laptop. Yeah, so I'll probably start it right now, and meanwhile I'll get my laptop fixed. Okay, so we have this linked list, and many of us already are aware what linked lists are, but many of us are not, right? And we would like to look at it a little slowly, because that is also going to give us an opportunity to create other data structures which are linked list based, right? So let's do that. Um, Not only for linked lists or lists, but also for all the other data structures that we are going to see. Um, just a minute. Yeah. So can somebody confirm that I am audible as well as the slides are visible? Yeah. Great. Great. Thanks a lot. So one of the important notions that is going to be useful is this notion of abstract data type. What does that mean? The abstract data type essentially means that whatever are the operations which are being done on this data structure, these are in some sense abstracted out. What that means is that you are kind of going to hide the implementation aspects and let the user of this abstract data type know only about the functionality that is provided by your data structure. Right, so let me try this one. Okay, just a minute again. I'm trying to log in from my another machine. All right. So okay. Oops. Other machine. Okay. Is there a problem? Uh, there is an echo coming from my side. Yeah, I'm just trying to figure out where it. Yeah, I have muted the other one. Sorry. Okay, thanks a lot for that. All right. Okay, so the abstract data type is going to define essentially the interface to the outside world, which is going to use that data structure, right? What that means is that let's consider array as a data type. What we mean is about the ADT as, I mean, array as an ADT is that I'm interested in figuring out that I can insert an element, I can remove an element maybe, I can edit an element, I can possibly find out the number of elements in this array. All of these are different operations which I support into this array data type. But there might be certain implementation aspects which I'm not making visible to the outside world. For example, if I am supporting that number of elements in this array is going to be decided by if I am keeping track of a counter as I insert elements into this array, or whether I have some sort of an end marker in this array which is going to tell me that these are the number of elements in this array, right? So this is an implementation aspect which I am not worrying about when it comes to the other outside world view. So therefore what I am providing is like an interface to the outside world, right? So this abstract data type is going to tell us only the functionality that is provided by the abstract data type, but not worry about the implementation aspect. So this is an important point which we should be aware of whenever we are designing a data structure. So it in some sense defines what this data structure does rather than how this data structure is implemented. In case of C or languages such as C, you cannot hide the implementation aspects, in the sense that if you have a data structure available, well, you also know how that internal implementation is and so on. To some extent it is possible, not always though, but to some extent it is possible when you decide the header file which provides the interface, and then the .c file corresponding to the implementation can actually be pushed into a library, right? So for example, currently we know what printf does, but we don't know how it is implemented, right? Because it is there inside some libc.so library file. Similarly, other functions, let's say string functions and so on. So this idea of that you are able to hide the implementation details is very important when you are dealing with a large software, and as you try to implement different parts of a software in a company, or some of you might have gone in an internship and experienced this, that it makes life easy because the user does not need to know how it is implemented. That is one part. So I just need to know the interface as a user of your library. The second part, more importantly, is that the changes to the implementation are possible without informing the clients. Clients meaning people who are using, or the codes which are using your library, your interface, your data structure. So for you, it becomes very easy to change the implementation, get maybe an optimized version, keeping the interface same. So then the clients don't need to worry about it. So this is very important point from software engineering perspective, which you should be aware of. Okay, so let's come to that list as an abstract data type. So what would be the functions which you would want to have in a list? So what are the functions in the interface of list as an abstract data type? Okay, Mayank says edit, add, delete. Aniruddha says order one, insertion, deletion. Okay. Okay. Kaushik says also size. Okay. So maybe I'm asking this question a little too early because I have not yet defined what a list is, right? A list is some data structure where you are inserting elements and you are maintaining it as some sort of representation of those elements, right? Okay, there is other. Murari says contiguous, order one, insertion and deletion. Pavan says is empty. Okay. So these are all interesting suggestions. Let's look at that a little carefully, because some of you have also mentioned about the complexities where that comes into picture that we'll have to decide. Okay. So as an ADT, as a list, I have a list of items. Now, what is that item? That is deciding the type which is going into each element of this abstract data type, each element of this list. How is that implemented in the implementation, whether it is implemented as an array or a linked list of pointers? Well, that is something which I would like to hide. I am not interested in how it is implemented. I am interested in figuring out what is the interface. And the interface essentially is what you guys have suggested, that if I have a class list, a class is just, think about it as a synonym for struct for now in C++. There are, of course, better functionalities which are available in the class. but for now it's okay. Public meaning that everybody can access those functions, right? So we have this list. Now list is a function which is defined inside that class or struct list. What does that mean? Well, it defines something called as a constructor. When I have an array, I typically want to initialize it with all the zero values, right? Or there could be other initializations which might be possible. All these initializations can be nicely modeled in C++ using something called as a constructor, which gets called automatically without you explicitly calling it as soon as you declare a variable of that type. So if I say that list L1, L1 is a variable of type list. So whenever you have a class, essentially that is defining a new type, very similar to our struct S1, struct S, and then opening brace, and then there are some data items, closing brace, and S1. So S1 is of type struct S. Similarly, class list creates a data type list, and therefore I can define variables of that type. So I can say list L1, and as soon as I say list L1, automatically the constructor function, which is in this case the same name as the class name, gets called. And that helps me initialize the internal data structure. Maybe if I'm using a pointer, I would like to either initialize it to empty or maybe allocate some memory and so on. In a similar manner, there is a notion of destructor, which gets called whenever an element goes typically out of scope. So whenever the element gets removed from memory, at that time the destructor gets called automatically, and at that time you can perform certain operations like you want to deallocate memory and so on. So these are some of the aspects which C++ provides. Don't worry too much about it. I'm going to show you the code. In case you have questions, feel free to ask at that time. Then I am also interested in the insert function, where I want to insert some element E. Right? What is the type of that element? That is capital element I have mentioned. And what is that type? Well, currently I have not defined, but I need to define that. It could be an integer. For example, that element could be a type def, right? So type def int element, or it can be a larger type. It can be a class in itself. Right? So class element, and then it can have certain fields, and that will be a new type. So all of these are possible. So for now, I'm just specifying element, or it could be in the context of C++, it could be a templatized parameter. There is a notion of templates using which you can create these. Where would we insert the element is what Kaushik is asking. Yes, that is a question that we have. However, that is again an implementation aspect. As a user, I don't care where you insert the element, right? If you are building this library, you are providing me this list interface, you figure out where you want to insert the element, whether it is an array, linked list, tree, graph, whatever, right? But yeah, we have to worry about it when we go beyond the abstract data type. Beyond this abstraction, once you move to the implementation, we would have to worry about it. And that is where the complexities will come into picture. And we'll discuss that in a while. Good. Difference between class and struct. For our discussion, class and struct are the same, except that even in C++, these are the same, except that the default visibility in class is going to be private, whereas default visibility in struct is public. Okay, so think about, so even if you declare it as struct list and all of this remains the same, you are good to go. Not an issue. It's going to be the same in C++. Any other concerns? All right. So insert is one function. What does it return? Well, currently I have said that it returns nothing. But you might have probably a better or a different design where you might want to say that whether that insertion was successful or not. And depending upon that, I might want to return a boolean or an integer. Right? So that could be another return type, but I have defined it as in void. The other one, I want to search the element. Once I have a list, by the way, by default, when I say list, the elements need not be unique. By default, when we say list, the elements need not be unique. If the elements need to be unique, you can as well call it a set. So find is an element. Finding an element can be another function. Currently, I have said that it returns void, but that doesn't make sense. I mean, how will I know that the element is found or not? I'm not passing an element also to it which returns the Boolean value, and I'm not returning a value also. So that needs to be corrected. So this should be, let's say, bool find element E. Okay. Then I can remove an element from the list, and that should also be fine in a similar manner. Okay. And then I can as well print a list. I want to debug or whatever. I want to print the list, and so all the elements in that list will get printed. What is the type of element? Well, again, that is decided by element. So depending upon what that element is, I need to have a printing facility for each different type of element. Right? So that also I need to define as a programmer of this data structure, ADT. And then size, as some of you have suggested. Right? So all of these form my interface of, I mean, abstract data type list. Right? Note that I have not said anything about either the complexity or the implementation. That doesn't mean that I should never say about complexity when I'm talking about abstract data type. In fact, complexity does come into play when I'm dealing with ADT. It's just that that complexity more or less depends upon the implementation, and therefore either you say that I'm talking about only the functionality provided, or you talk about the ADT having this functionality with the complexity requirements that you have, and depending upon the complexity requirement, you can decide how the implementation will be. So if we have to worry about the complexities of these operations, what will you say? Insert will be? Okay, Mayank, Aniruddha, Kaushik say order 1. So let's think about this. Why will it be order 1? Pavan says order n. Why will it be order n? Any suggestions? We have to traverse. Okay. So all the elements, Murari says order n if we consider finding that element. No, we are talking about insert. I mean, for now, just insert. Manichandran says depends on how elements are. Sorry, I didn't get that, Murari.
Hello?
Yeah.
Finding that element also takes time. So finding that, I mean, the position and then inserting.
So there is no ordering amongst the elements, right? So when we said list, there is no ordering, which means that you can actually insert the element at the start of the list, at the end of the list, somewhere in the middle, you are good.
Oh, okay, so O of 1 then, okay.
Right. So the list interface neither said anything about that the elements are ordered. It also did not say anything about whether the elements are unique. Right. So, and therefore, there are different possibilities. Mayank says we can have a track of last element, then it's order 1 insertion. Okay. Naimisha says then order 1. Kaushik says if we know the pointer value of the position of insert, can we not directly insert in order 1? Okay. So all of these are important questions, and we need to be careful and we need to decide how the implementation is going to be to decide on the complexities, right? So that is what kind of leads to different complexities, and I'll come to the complexities in a while. But let me have a couple of minutes spending on that. What is the meaning of an abstract data type? What that means is that if I take, let's say, fans regulator as an abstract data type, right? Why is it abstract data type? Because I have the interface provided by the regulator that I can increase the speed, decrease the speed. I can know what the current speed is. I can also know possibly the company name and so on, right? But I don't need to know how the internal connections are there, whether there is a red wire or yellow wire, or whether there is neutral and live and so on. I don't need to understand all of electrical engineering that I have forgotten long back to understand, to use the fans regulator, right? Similar manner, when I'm talking about a type like integer that is provided by a language, I can know what is size is in terms of, let's say, number of bits or bytes. I know whether it is signed or not. I know if it is what its value is. I can set its value. I can perform certain operations like addition, subtraction onto it. but I don't need to know how it is stored. Many times, I mean, of course, in C you will precisely know how it is stored because there are bit operations that are supported. But if I'm talking only about the integer and not about the bit related operations, then I don't need to know how it is stored. For example, in all our discussions, we never worry about whether the byte order is from least significant byte to most significant byte or most significant byte to least significant byte. And in fact, that can differ across machines. Right? What am I talking about? If the byte order differs, what does that lead to? Anybody aware of that? It's called endianness. It's not Indianness, it's endianness, END. Right? So we are talking about the big endian and little endian storage of these 4 bytes, right? Not necessarily 4 bytes, but in case of integer. So the most significant bit might be stored first in some memory location, then the next one, then the next one, and then the next one. That is called as big endian storage. Whereas on Intel architectures, actually it gets stored in the opposite order. First you store the least significant byte, then the next one, then the next one, and then finally the most significant byte. So this we never worry about. As I could see from lack of response, you were not even probably aware, many of you, that such a thing exists. So the implementation is somewhere hidden. As soon as I know integer, I just worry about the integer part, right? So that is what is the power of an abstract data type. One final example, let's say student type. I can get the roll number, I can get the hostel name, get the favorite game of that student. I can also set the hostel, get the slots in which that student is busy. I can set the CGP and all of this. These are all different functionalities. How it is implemented, I don't care. Right? So that is what is the notion of ADTs. I just thought that I'll give these examples to make you aware. Any questions on this ADT part? Okay. So then let's come back to our list data type, right? So we were implementing this list. Let's for now implement it using an array, right? Now I'm specifying that I'm implementing this list data type as an array. Now what can you say about the complexities of, let's say, insert? Okay, order one, and each element is connected to the next element. Once we are in appropriate position, we get order 1 insertion. Okay, so all of you are ready to agree that it can be done in order 1 type. Okay, so let me show you that, right? So Naimisha says it will have a limit on size. Yes, that is also correct. So all of these are going to be coming into picture as you start defining now the actual implementation of that data structure, right? So I'm just storing these elements in some order. Again, you can see that there could be repetitions and so on. So this is my list. So you have an array which is fixed in size, at least initially, because we said we defined array as it has a fixed size. You can change it by reallocating and copying and so on, but there is a fixed size. And I'm going to go on inserting elements. In which order should I insert? That is also something which I have to decide. So there are these design decisions when you are getting into the implementation aspects of an abstract data type, right? What are those design decisions? Exactly the questions that you guys were asking, or exactly the questions on which our complexity was dependent, right? So what is the size of that? Right? I don't know the number of elements that you are going to insert. As a user, I don't know how many elements somebody is going to insert. So how should I define the size of that? Right? Whether it should be 10, 100, 1000, whatever, million. Can I maintain size separately or use a sentinel? What does that mean? Can I maintain the size separately or use a sentinel? What does that mean? Okay. So if I want to know, okay, Salman says use an element to store size in the array itself. Yes. So not array itself. In the list data structure, in the list ADT, I can have a variable which is keeping track of the array size, right? I mean, in general, if I'm talking about C, C++, I don't get the length of the array, right? So I need to keep track of. So one way of doing that is that I keep track of how many elements exist in this array. So that could be maintaining a size separately. In contrast, I can use a sentinel. What is a sentinel? Any suggestions? Has anybody seen sentinel in any of our C related data structures? Okay, so Sentinel is actually a special. Murari says no. Sure, Sentinel is a special value, right, which you use to. In this case, I mean, you can use it for specifying multiple things, but in this case, you will use a Sentinel to decide the, in some sense, size of the array. Right? So, have you seen that Sentinel somewhere? So for example, in this case, I can have, let's say -1 as a sentinel value because all the elements that I'm going to store suppose are positive, or minus int min, something like that, right? Or even int max. Others says in circular linked list, yes, that's possible. You can use a sentinel value, but something which you have probably come across many number of times. Type of for loop, Sampriti says. I am not able to see how. If you could explain, that will be good. Naimisha says insertion sort. My God, you guys are thinking too much. Yeah, there also I don't see. You'll have to explain. Kaushik says, can we use pointer value to find the size? Okay, that could be another way. But maybe I gave too generic a definition that you guys are thinking too much. Okay. Counters in loops. Oh, I see. So you mean that it goes to n and that becomes a sentinel value? Maybe. Bit to denote sign of integer. Okay. Ashwin Krishna says, is it like /0 at the end of a string, right? So that was what I was thinking in mind. But maybe some of your answers might also be applicable, although I don't see exact relationship. So /0 is not a valid character in some sense. I mean, not a valid character. It is of course an ASCII value, a correct ASCII value, proper ASCII value, but that gets used to decide the end of the string, right? End of a character string, and that gets used as a sentinel. That's a special marker which defines the end of the string, or in some cases. Yeah, so I think that's fine. So I mean, I was just thinking about that in some cases you can have control D or character number 4 to define the end of file marker on Linux systems. But yeah, so /0 is probably a very good example. And you might have such a sentinel for these character arrays. In a similar manner, you can decide such a sentinel value. -1 is going to mark the end of the list, right? In if we are talking about integers, positive integers. Right? So that could be, so that is called as a sentinel. So whether to, if I maintain a size variable separately, then I don't need to worry about sentinel. If I have sentinel, then I don't need to keep track of possibly the size of the number of elements. And both of these have some design choice because there are positives and negatives. What is the advantage of maintaining a separate size variable versus a sentinel? What is the advantage of maintaining a separate size variable? Size of the array is maintained as an integer rather than using a sentinel. Let's say -1. Okay, Dileep says instant, don't need to traverse every time. Mrityunjay says, Aniruddha says int size function size of which is order 1 if size is variable. Shania says we can get size of the list in order 1. Andrea says we might have to traverse through to find where sentinel is. Pavan Dileep Kumar says getting size easily without calculation. Naimisha says size needs to be updated every time, right? So that is a disadvantage. Which so Naimisha has already gone to my next question, which I had in mind. Good. So all of you are correct that if you have a separate size variable, then if I have this size function, right, which I have as the last function of this ADT, that is order 1. You don't really need to traverse the array to figure out where the sentinel is, which means that string length function in C is of the order of n, where n is the length of the character array. Whereas if you maintain a variable, then that will be a separate variable, then that will be order 1 without traversing the array. So that's good. But then the downside is what Naimisha said, is that we need to update that size every time. We need to update that size variable every time we make an insert or remove and so on, right, from the list. So that maintenance activity you have to do, whereas it might become a little easy to continue having that end of array character or end of array element which marks the sentinel. Okay, so that is also one design decision which we have to make, right? If it overflows because we are talking about the fixed size, then what do? Do you just give an error, or do you do reallocation and start copying and so on? So that is also a design decision. Similarly, there is an underflow possible, right? So if you are removing elements and the array is empty, list is empty, what do? Again, you can think about error message or exit or just keep silent. That could be another design decision which we have to make. Right? What should be the printing order? Because we said that the elements are unordered. While printing, should you print those in a sorted order? Or while printing, you just print it in some order? I mean, is there a guarantee that you can give that the elements are going to be always in the exact order of insertion? Or can you say that the elements will get printed exactly in the opposite order of insertion? That could be another way in which it can be done. Kaushik says, won't maintenance of size also requires order n? Even when size is not required, we would be maintaining it. No, it's more like saying that if I'm inserting an element, then I increment that counter by 1. If I'm removing an element, I'll decrement that counter by 1. But yes, there are other, I mean, as far as maintenance of that counter is required, right? So that you can do with plus, plus, minus, minus. But the overall operation of insert, whether that will remain order 1, that is not clear. It depends upon where you want to insert it. So suppose I allow you to insert at a particular index, then I need to probably shift the elements. But in list, probably that doesn't make too much of a sense the way we have defined it. And therefore, we can actually insert at the end and just increment the counter. That can still be order 1 operation. Does that seem reasonable, Kaushik? Yeah. Okay. Any other questions here? Okay. Whether to allow duplicates, in this case, we have said that we allow duplicates, but maybe some list might be, I mean, you might not want to have duplicates in your list because maybe I'm maintaining a list of students in the class and I don't want clones to be there in the class, right? So I might disallow duplicates and so on. Right? Typically, that gets converted into a set instead of a list, but that could also be your design decision. And in case you allow duplicates, when you remove an element, which element do you remove? Do you remove the first instance? Do you remove any instance? Do you remove all the instances? Right? This is something also comes as a design decision. So this needs to be thought about even before starting to code. So before starting to code, you define the interface, and from there you try to make certain design decisions, having some idea in mind that I want to implement it using an array or a linked list or whatever is the data structure that you have in mind. Naimisha says, if size a static data member, because size for every object might be a waste of space in an array. No. This list is going to keep track of all the elements. So the array is going to be part of this class list. So the array is there and we are not maintaining the size element with each element of this array, we are maintaining array and the size as two different variables in this structure list. Right? So this list is a structure. Within that there are two elements. One is the array and the another one is the size. So when you insert elements into this array, you also update the size variable and so on. So it need not be in fact, it should not be a static data member. In fact, in this case, because you can have list L1, list L2, and their sizes might be different. If you keep only one static data member, then that will be shared across the two lists L1 and L2, which is definitely not correct. So we will have to have it as a non-static data member. Anantu says size can be different for each object. Yes, that is correct. So list L1, list L2, list L3, and for each of them the sizes could be different. Therefore, these should be non-static. Mayank says, what does static mean here? Static in this context, if you have a static variable inside a class or a structure, then all the instances of that class or all the variables which are created of that type, they all will have a common element. That is going to be shared across all the instances of that variable, instances of that class, right? So think about it this way: when we have a static variable inside a function, that static variable is kind of shared across multiple invocations of this function. Even if I call it once, twice, thrice, etc., all of those are going to use the same copy. There is only single copy. Similarly, in case of class, if you make L1, L2, L3 as different objects of that type, these are essentially variables of that type. They all are going to have a single copy of this static variable. That can be very useful if you want to count, for example, the number of lists that are created in your program. If you want to count the number of lists that are created, then you can have this static member as part of your list, and you just increment it inside the constructor, and at any point and decrement it in the constructor, and at any point in time, if you query what is the value of this static counter, you will know how many instances are currently live. Right? That can be very useful in some cases. For example, if you want to do garbage collection and so on, that can be very useful. On other instances, it can be very useful. For example, you are just interested, let's say you have a multi-threaded program and you want to know how many threads are operating in the system. Right? So you have a thread class. Within that, you can have a static variable n threads, just as an integer, static int n threads. And you increment that as you enter the constructor of thread, you decrement that when you enter the destructor of thread. And if you do a get thread of this, or you mark this static variable as public, then you will be able to find out how many threads are currently active in your library system. Any questions? So, static is not really our concern, but since it came up, I explained it. But yeah, you can do it without static. In this case, we will not require static because you are maintaining an array completely. I'll show you the code, so it will become a little clearer. Any concerns? Any further issues? Okay, so the takeaway here is that you need to worry about these design decisions, right? Before implementing, right? So if we, and there are more, right? So if we fix all of these, that I'm going to have certain design decisions done, then I can say that, okay, I can insert in order one, maybe maintaining size variable. Find can be order n, because I'm talking about an arbitrary list. In fact, whether, of course, you should change the return type of find to maybe a Boolean, or it could as well be an array in itself, right? The return type could be an array in some sense. Not array as such, but cannot return an array, but maybe a pointer to a memory location which contains multiple elements. So you can possibly return an integer which says how many times that element exists. It could be 0, which means that the element is not present, or it could be the number of times that element is present. Removal of an element might take order n time, whether you allow duplicates or not. Printing will definitely be order n. And now in this case, n is the size of the array, right? Not the number of unique elements, it's the size of the array. And then size could be order 1, and so on. So any questions so far with the complexities? And you can visualize that as you get into these complexities, you will have some idea about, okay, I can see how the implementation is going to be, right? For example, in this case, we not only fix the array implementation, but we also fix some design decisions with respect to array, but not possibly all. You still have some flexibility before implementation. Okay, any questions? Okay. So then I am also going to, okay, there is a question here, size is stored as a variable, yes. Otherwise we cannot get the order 1 complexity for the size. Remove could be order 1, yes, possible. If we assume that the elements are unique, you can still have a design decision such that you can make order 1, but there is a possibility that either you can have multiple elements, that is one. The second thing could be that you might have to still search that element, and therefore if you think that searching is already done and you are just giving the index or somewhere position of that element, then it can be order 1. But otherwise typically you would like to search that element also, and therefore the removal turns out to be including the search, and therefore it will still be order n. Mani says, if we insert at position 1, rest of the elements have to be shifted in order n time. Yes. So if you make that design decision, then the insert will be order n. If you're inserting at the end, then it will be order 1. Correct. Andrea says, if size is stored, yes. You should store the size. Otherwise, you cannot do int size in order 1. Kaushik says, either size or the tail index, right? One of that. So Kaushik says all n variables are same, have to be removed, right? So in this case, definitely you might require order n time. Correct. Murari says, but using array, it's order n anyways for deletion. That is correct. If you include the searching operation, which is what is expected out of this remove, because you are providing element as the argument, you are not providing the position in the array, in which case it is still going to be order n. But if you provide a position, what you can do is that you can just mark it as deleted. At that time, you can use a sentinel, which marks it as, okay, this element is deleted, and just return. That can be order 1. So that is what probably Andrea was suggesting. Aniruddha says, is choosing array to implement list also a design decision? In some sense, yes. In some sense, yes. It is also a design decision, because list as an ADT typically does not worry about how the underlying implementation is, but it so happens that most of the times we are interested in identifying the complexities of these individual operations. So it turns out to be, so typically the way you will be given this problem, or the way you will think about this ABDT problem, is that you want this list data structure, and you want that the insert and remove are, or remove is a very rare operation. In a real world scenario, suppose this is how you will be given the requirements. Remove is very rare. Printing is also a little rare, but you can't do much. Size needs to be fast. Find needs to be fast, and insert is also common. Find is more common than insert, right? So this is how your requirements will be given. You might also get the quantification of all of these. That is 1 million inserts. Find was 10 million. Remove was done 100 number of times. Print was done maybe 1000 number of times. Size was called let's say 100 million number of times. So all of these is the requirement given to you. Based on this profile data or requirements data, you will decide what should be the complexities of these operations, and then you will decide a particular data structure which is going to be appropriate for those complexities. Any other concerns?
Sir?
Yeah, go ahead.
Yes, so when we are like defining that abstract data type, we are just saying it is insert, find, remove, print functions are there. We have not specified the functionalities, right? So what exactly will the specification be given to us? Will that be given as part of specification, or is it a design decision?
No. Okay, so this specification will be given by the user. So when I am talking about that, I want a particular data structure. Let's say that I have I have to design an email inbox, right? So what are the operations that a client is going to be interested in, right? So the client is going to tell us, okay, I want this email service and I want this interface of emails. Now the client might give you some functions and you might have to think about some functions on your own. Client usually is incomplete. He or she might not give you the complete specification. So you will have to think of different functions also. So you will say that, okay, inserting, when a new email comes, inserting an element into the inbox, right? So that is one operation. Then I want to search using keywords into the titles, or maybe I want to search across the bodies of the emails. That could be another function. I want to sort the emails based on certain criteria. It could be time, it could be based on, let's say, the sender name, etc. So all of these are different operations which a user is interested in. So that user need not be a final client who is using your email service. The user might actually be another team in the same company which is making use of your library or your class. So they are going to tell you that these are the functions required. You are going to think about that, okay, there are other functionalities which I can provide. For example, I might allow schedule send or something like that. Related to my email service. So all of this is something which you are providing for these operations. What is the best data structure, considering that these operations are going to be run more number of times, these are going to be rare. So let me have higher complexity for rare functions, but I want the common functions or usual functions to be having better complexity. Right.
Okay, sir, got it. Thank you.
Any other concerns here? Okay, so we'll probably think about the linked list as a backend data structure for lists in the next class, because we are already out of time. So I'll be here for some time in case you have any questions. Otherwise, if you have a class, feel free to go ahead. How is HackerRank assignment graded? It gets graded from the test cases. So we will have some small test cases. Some of those will also be public. Some of those will be medium size. Some of those will be very large. And so HackerRank is going to run your code with those test cases. So there will be an expected output. Many of the test cases are going to be private. So you will know if your code is working on those test cases or not. That is, it is passing those test cases or not. Right? So far, we have not thought about doing a manual check of the test cases, but we might have to do that, or at least we will run some script to just probably check if some people are implementing it correctly or not. Correctly meaning, it's expected that in this assignment you have a linked list rather than using a matrix, right? So you can do it with matrix and get the same functionality, but it is going to be not expected. So you should not be using a matrix. So we might have to run some small script when we download the codes from HackerRank to run MOS. At that time, we might be wanting to do some checks. Right? But the grading is by and large being done on HackerRank. We'll just do some safety checks later. Any other concerns?